Okay, part 2. See if I can get these within 3 videos. All right, so let's talk about the position of the Earth with regard to our seasons. We experience the seasons that we experience, at least with regard to our hemisphere, and we are fortunate to get all 4. It's a little different at the equator. We experience the seasons that we experience because of our axial tilt. If you look at the top, right, that is, as opposed to having an axis that is straight up and down and a perfect basketball style spin on your finger or a top, whatever the case is, we have a slight 23.5 degree tilt. That 23.5 degree tilt allows us to have the 4 seasons. In our orbit around the sun, in our elliptical orbit, when we are facing towards the sun, when this tilt is towards the sun, it's our summertime. When we are tilted away from the sun, it is our winter time. Photons, light particles, energy from the sun leaves the sun and it travels to the earth in parallel lines. So these parallel lines hit the earth evenly, but at different spots. There's a concentration of sunlight at the equator. That's why the water here is warmer. And again, depending on the time of year, you get either more or less sun, depending on whether you are tilted away or towards. Seasons, of course, are different, also based on hemisphere, north versus south. I'm going to ask you, please make note of this. Also make note of the equator. It's important because season or sun, the amount of concentrated sunlight depends on the position of the equator and the hemisphere and the sun. And again, summertime, summer solstice, June 21st, we get the most amount of sun. It's the longest time of the year. The clock after, so let's say June 20th, 21st is the solstice. That's the longest day of the year. 22, 23, 24, the clock begins to tick down. Every day is a few minutes shorter until eventually we get to your autumn, your autumnal equinox, right? September 21st, 22nd, depending on the year. At that time of year, if you're looking up at the screen, 12 hours a day in the southern hemisphere, 12 hours of day, or 12 hours of night, 12 hours of day, 50-50 in the northern hemisphere. The sunlight is directly over the equator. So if you're at astronomical noon, the sun is directly overhead. You have no shadow at that equinox. And then the clock continues to tick down, few minutes until we get to the winter solstice, December 20th and change, and that gives us the shortest day of the year. Notice the axial tilt, and notice where the sunlight falls below the equator. So there's the least amount of sunlight on the northern hemisphere. But let's say that's the 22nd is the winter solstice. Well, the 23rd, we start adding time, a few minutes until we get to the vernal equinox, which is just like the autumnal, but for spring, 12 hours, and again, if you found yourself on the equator at astronomical noon, you'd have no shadow. Add minutes until we get to the summer solstice. Process repeats. Summertime, the sun is at its zenith. It's at the highest in the sky. Wintertime, your zenith, the sun is at the lowest point in the sky. When it's I'd say directly overhead, but not overhead, at its peak before it begins to set. Notice the amount of sunlight you would get during the day here, the amount of sunlight you'd get during the day here, hence the temperature difference. Because of that, you can, if you're an astrophotographer, you can use your camera, and if you have a solar filter, you can take pictures of what's called an analemma. An analemma is the pattern that the sun makes in the sky throughout the course of our 365-day journey around the sun. This, if you're looking at the analemma, this is the peak. This is the summer solstice, and if we go down to the bottom here, this is your winter solstice. This is when the sun is at its highest point in the winter sky. This is when the sun is at its highest point in the summer sky, and here you have your equinoxes. Now, this analemma is different depending on your latitude, where you are and what hemisphere. It would be higher or lower in the sky. Let's see if we can get this video to work. This is This is a picture of a solar analemma in Edmonton. That's in That's in Canada, above Montana, a few hundred miles. I think Okay, play the seasons. Oh, lovely. All right. So this, and what's cool about this is, so here we have our summer solstice, right? So what's cool about this is you can actually watch, if you take your eyes off the analemma for a little while, you'll watch the seasons. Now Edmonton's high, right, latitude-wise, so we just sort of shifted into fall. So you'll have a very low winter solstice. Right? I think the bright sun signifies the winter solstice. And so now we're into winter, January, February, I would assume. And you know, these are of course the coldest months, but you can see you add a little bit longer, the days are a little longer, a little longer, a little longer. Spring, obviously the change of Vivaldi Four Seasons in the background. All right. Your analemma, compliments of a very cool photographer. I'll skip those. And this goes with, and these were in the notes that I sent you, so depending on where you are, what part of the earth you are during these seasonal milestones, any one of these times, you can kind of go on an astronomical journey. If you want a reason to go somewhere, if you want a reason to go to the Tropic of Cancer or the equator, or below the equator to the Tropic of Capricorn, you can go at your solstices or your equinoxes, and at astronomical noon you can go out to picture yourself and be like, hey, no shadow. Look, it is significant. It shows you the mechanics of how the Earth moves around the Sun with regard to its axial tilt. If you want to do that without logging on and using your phone and any of those modern modalities, you can just go and stand and put a stick in the ground and prove that we are moving around the Sun at a 23.5 degree tilt, depending on where you go. Equinoxes, no shadow for autumn and autumnal and vernal. Summer solstice, Tropic of Cancer, no shadow on June 23rd. And if you wanted to travel in the wintertime, Tropic of Capricorn, astronomical noon, you'd have no shadow. This is 101 stuff, but we just got to talk about it quick. Longitude versus latitude. Lines of longitude, they go from pole to pole. They are 15 degrees apart. Each 15 degrees marks 1 hour. It's 0 in Greenwich, England. 0, 15, 30, 45, 60, 70, and it goes on and on and on. We are our particular spot on the globe. Oh, just real fast for latitude, same as you have a start off point, that's the equator, that's at 0, 0, 10, 20, 30, all the way up to the poles at 90, same thing, north and south. We are 41 degrees north, so 0, 10, 20, 30, 40 plus 1 degrees north, and we are 75 degrees west. So if we were at Greenwich, England, the prime meridian, right, 0, 15, 30, 45, 60, 75. So 41 by 75, that's Ramapo's coordinates. This is important. Everything now is coordinate based. You move around the planet based on coordinates. We are lucky to have them. Back in the day, it was just using azimuths and sextants to use guided with the constellations and stars. You'd have to do these readings yourself. Nowadays, we just punch in our GPS and bang, we wind up there. But like longitude and latitude on Earth, if we want to find celestial coordinates, it's the same thing, except there's a grid that wraps around the planet. That grid is called a celestial sphere. The celestial sphere is the entire grid. Instead of longitude and latitude, we have what's called ascension, that's these lines going up and down, and declination, that's these lines going horizontally. So the longitude is ascension, the latitude is declination. Every star, constellation, celestial object has a celestial coordinate to it, and that is found on the celestial sphere. The celestial sphere has declination, ascension. We've talked about zenith, that's the mark directly above your head. And half of the celestial sphere, when you're standing outside, your view, 360 degrees around you, your view is your celestial horizon. This is what the celestial sphere would look like to us if we had imagine a cage wrapped around our planet, right? And we were staring out into the coordinates of the night sky. This is the ecliptic, the path of the sun. This distance at its maximum in the ecliptic between, this is the celestial equator right here, this is Earth's middle, this distance is 23.5 degrees. So if you were standing outside, and this is a good animation here, if you were standing outside, directly over your head marks your zenith. That's the point above you, right? Every object has a zenith. Now, it might not be directly over your head, but it's that object's maximum height in the night sky before it goes down and sets. That's its zenith. I asked you to find the zenith of these objects when I was asking you to use your star chart. As you spun, I said stop in the middle. That's your midpoint or your season. Well, that marks an object's, a constellation, or a star's zenith. Your zenith is measured also by altitude. Altitude is the distance from the horizon to however high that particular star is. It goes, of course, in degrees, 0 up to 90, and then back down. And then there is a compass that surrounds us, and that compass reading is called our azimuth. Your azimuth, let me see if I have an azimuth. I'm going to go fast just to find an azimuth. Yeah, your azimuth is marked, north is 0, south 180, right? So 0, 90, 180, 270. So if you're standing outside and this is your horizon, your celestial horizon is the circle. All of these marks. So if I said, hey, face 45 degrees on your azimuth, and you would have to face northeast. If I was asking you to find Polaris, right? Polaris is a northeast circumpolar star. So please find Polaris. So azimuth reading of 45 degrees. I said if you had an azimuth reading of 90 degrees, that's the, maybe one particular night the moon has a perfect rise at an azimuth of 90 degrees. It's rising east. The moon might have a set of 300 degrees. Well, it rose at 90 and it set at around between 270, almost northwest, right? So that's your azimuth reading. Let me go back real fast. Sorry, I appreciate you sticking with me. All right, I'm going to pause here. I think we can get the last one in.